notice in the story? Carly.
That they're doing arrays, like,
A little louder. Oh, I can't hear.
they're doing arrays,
Okay.
like, there's 100 ants, so like, first they were doing 2 rows of 50, or 50 rows of 2.
And what do you think they were doing that for? Ethan.
To get food, or because they were hungry.
Now, what strategies were they using? Cassidy.
They were using
Multiplication. Gannon.
They were using the strategy that they were using was a array strategy.
Okay, array strategies. Now, do you think that it was effective? Andy?
Yeah.
So why do you think that?
Because usually they were just going in the same speed, but still they just got there. So that's why.
Cassidy, do you want to answer that?
Usually, they would all like merge and get there at the same thing in one row.
Mm-hmm.
It's just usually fast because they're not in different rows and trying to stay in between lines, and they're not like switching every time to make different grades.
Okay. Jocelyn.
I think that in the book that the ants multiplication because they're in rows and how to figure out the problem, the multiplication problem, you have to count how many rows and columns it has. And then
Yes, I think that they were trying different strategies to get there faster. Now, does it mean that they were wrong for trying different strategies? Or right, or is there a right or wrong way? What do you think, Nick?
They were right.
Okay, yes. All right, so now we are going to do a little experiment. And I heard Miss Gary earlier discussing arrays, and do you know what that means? This table's quiet. Jose, what do you think that means?
We're gonna multiply.
Okay, what do you know what an array is? An array, when we use array modeling, what do you think that means, Cassidy?
An array, it has rows. It can have down to 1 row, and like those shelves, that's an array.
Good job, good observation. Now an array is an arrangement of objects, pictures, or numbers in columns and rows, just like Cassidy was saying. So I have some examples here. Okay, so let's look at the board. Now this array shows 4 rows and 3 columns. So when we counted, what do you think that we can come up with as far as multiplications if we are doing, what do you think, Gannon?
If you're counting it, you could do 3 times 4
Good job.
equals 12.
Okay, and if we want to check our word, what would we do?
You would count how many is down 4, and you would count the first row how many. There's 3, so you would go down 3, 6, 9, 12.
Correct. And now if you were to count them all, then you get 12. So this is another sample. So this array has 5 rows and 4 columns. So what observations? David, what can you tell me about this one?
5 times 4.
Okay, and which is?
20.
Okay, and good job. And now if you wanted to count and verify your work, you can always count the triangles again. So here's a little sample on how we can use this, as you guys were just saying. And there's different ways. We just said different and see how many intersections. And I will explain to you in one moment exactly what I'm going to do, and we can do it together. So can I have a help, actually? If you guys have the glue sticks like Carly, can you please take it out? It will be easier than just using regular glue. Extras, just leave them on the side of your desk. Now, we are going to take our index cards. If you guys look up here, and you have 7 of them. So we are going to put, we're going to glue 4 toothpicks in a parallel column on the index card. Then you are going to place 3 toothpicks across. So we are going to go like this. So and you don't need too much glue, just enough for it to kind of like not run away from you. And then once you're done, you just very lightly, you can grab your toothpick like this and just kind of rub the glue on it. And just literally just put it right on top of it because it does not need to be perfect. And you're going to put 3 toothpicks across. And this should only take 1 minute or less. See, mine does not look perfect, so. Okay, so if you need a buddy, and then you can figure it out that way, okay? So does everybody know, raise your hand if everybody knows what an intersection is. Okay, so what we mean by intersection is, is the one that crosses. So you see how these cross? That would be an intersection there on the dot. Now do you think that up here, is there an intersection here? No. No, okay. So now what we're trying to figure out is how many stoplights do you think that we need? Okay, so you have a few minutes, so go ahead and try to figure out with your buddy. And okay, so we have, remember the example how Janet was telling me that we had the different columns and rows. So right here we have 4 different streets, and then we have 3 different avenues. Now if that's confusing for some of you guys, it really is just this. So let's forget about that piece of paper. So we're trying to figure out how many stoplights we need. So each place where the toothpick meets, that's going to be a stoplight. So I need you to tell me what you think and how many stoplights you think that we need on here. So let's take a couple of minutes to figure that out, okay? And I will come around to help you. Carly, the dots are the intersection. So look, right hand right here. Okay, so that would be the intersection. Exactly. So how many intersections do you think we need? That's the question. So how many? Everywhere they need, you're gonna tell me. So number of streets. Okay, and how many, there's 4 streets and 3 avenues, so how many stoplights do you think?
What do you mean listening?
Okay. Stoplight explaining me. So how many?
Like it goes like this together. And then you give me that. I don't know. Like you only get like plus 8.
Yep. Because you have to put it Okay, boys and girls, so I see that some of you guys are confused, okay? So, if you think you figured it out, raise your hand. Okay. Gannon, please let me know your thoughts and how many stoplights do you think that are in this problem?
I think there should be 9 every intersection. There should be a stoplight.
Now, why do you think there should be 9?
Because when people are going like this and coming from all
Okay,
four
come
ways,
show me on the paper. And here, and you can use your pencil to show me what your thoughts are.
I'll do all of the intersections
Okay.
because when they're coming from all 4 ways, you just don't go
Jose,
because that's the only way to get a car crash.
okay, so Gannon said that he thinks there should be 4 stoplights. Okay,
No,
who
he
ca-
said 9. I said 9.
I'm sorry, a 9. So who has a different answer? Jose?
12.
12, okay. Why do you, actually come up here and show me, why do you think it's 12? So, show me and the class how you came up with the answer. How did you get 12 on here?
Well, first I thought you said is it the avenue or the street?
Yes, okay, so the avenues and the streets, so there's 4, okay, so.
When they connect, there's one here,
Okay.
one here, one there, one
You
here,
can do the circles if you want, so everybody can see how you came up with your answer.
one here, one here, one here, one here, one here, one here.
Okay, perfect, so that is?
12.
Okay, perfect, okay. Now, on your paper, so then we have, so since we're trying to do different ways of multiplying, what do you think that when we write out the problem, what that would be, Gannon?
I think it would be 3 times 4.
Absolutely. So then this problem right here would be 3 times 4 equals, how many stoplights did we say? 12. Okay, good job. Okay. So now, did everybody understand?
Yes.
Yes. Okay. So now individually, we're going to try. I'm going to come around and give you 3. Actually, let's add 2 more. And once you figured out the intersections, I want you to write it on your index card, okay? We're not yelling out the answer. I want you to do this independently, and I'm going to come around. This is going to tell me if for sure you understood the lesson, okay? Yes, Carly?
I forget what the intersection is now.
Okay, perfect. All right.
No, I said I forget.
The intersections are the meeting.
So like the stoplights.
Yes, the stoplights. So the intersections are when it meets like this, the toothpicks, that's one intersection. So we're trying to figure out how many stoplights do we need. Now, if we are adding an extra toothpick, I want to know what the problem, write down the problem on your index card and also tell me how many intersections. Okay. It's okay. No, go ahead. Yes, you can. Listen, you can add, look, you add it right here. Okay, boys and girls, this is an independent work. There should be absolutely no talking. If you need help, just raise your hand and I will come around. Mitch, come on. It's okay. They don't need to